Hi everyone, welcome to this video. Today we're going to be talking about sidecar containers. So before we dive in, there are a couple of concepts that I'm hoping you're familiar with, such as containers, pods, nodes, standard output, REST APIs. So I'm really hoping that you're familiar with Docker and Kubernetes and have done a few projects with these tools. If you do not have experience with these things, then you can still follow along and you'll benefit. However, you'll get the most benefit from understanding these concepts beforehand. Without further ado, let's dive in. So we're going to paint a scenario and pretty much talk about the problem in this scenario and the solution. So imagine we have an order service, a microservice that basically processes orders from your customers. It's just a REST API that's pretty much doing one particular task, right? And while it's doing that task, it writes log files, or it writes the logs to a file, requests.log, right? And what it's writing is pretty much, it keeps track of every API call that's recorded, right? So what was requested, did it succeed, did the order succeed, and how long it took, right? And your team needs logs shipped to Datadog within seconds and not minutes, right? So the logs vanish when the pods restart. So how do we handle this problem? How do we enable observability, right? We need to capture those logs. We need to find a way to make sure that the logs that are being generated or produced from the service somehow make it to the proper platform that we're using. And in this example, it's going to be Datadog. So one solution is we could modify the app. We could go inside the order service code and add some additional code and change a couple of things up, such that or allowing it to send logs directly to Datadog, right? However, now your app is going to have to handle a couple of different things, right? What if Datadog is down? What if the network is slow? What if your credentials expire, right? If Datadog is slow to respond, your customers wait longer to place an order because you are adding additional code that basically your service now depends on, right? You've added a bunch of code that has essentially nothing to do with processing orders. And that means that a logging problem can now break your function, can now break your code. Well, that's not a good solution. Another solution or an alternative is sidecar containers. So with sidecar containers, we can leave the order service alone. We don't need to edit any of the code, right? It's going to write to the log files on disk as it always did, meaning it's not going to, or we're not going to try to send the logs directly to Datadog. Instead, what we'll be doing is we're going to add a small sidecar container that reads those log files and streams them out to standard output. Now they share a volume, basically like a shared folder inside the same pod. And the main app doesn't have to know that the sidecar container even exists. And from there, a log collector called FluentD, which we'll talk about in a little bit, which exists on every node, picks up those logs and delivers them to Datadog. So no extra work is required from the app. There's no extra code that's needed. So when we talk about shared volumes, this is specifically the part that I'm hoping that you're familiar with, meaning that I'm hoping you have experience with Kubernetes. So this code snippet should look familiar to you if you do have experience with Kubernetes. Basically, a shared volume is kind of like a shared folder, as we've mentioned, right? Because by default, each container inside of a pod, even if they share the same pod, they cannot see each other's files or folders. So there's got to be a way, we got to enable both containers to be able to see each other's folders. And in this scenario, we need the sidecar container to be able to look at the folders and files inside of your order service application, right? it needs to be able to see what that requests.log file has inside of it in order for it to capture that and stream it to standard output, right? So this is a code snippet that you can use if you have a familiarity with Kubernetes. So we need fluentd here as well. And basically, when the sidecar outputs the logs to standard output, that's pretty much the end of the story with regard to the sidecar. But what picks up those logs from there, right? This is where fluentd comes into the picture. Fluentd is a log collector that runs on every machine in your cluster. And it's always watching for new logs, right? When a container writes to standard output, Kubernetes saves it to a particular file on the machine, on the node. And fluentd is going to read that file. So fluentd not only reads it and sends it to Datadog, it also has a couple of other capabilities. It handles log collection, as we've already discussed, and it also handles retrying if Datadog is down and authenticating with Datadog's API. So the sidecar turns a log file into standard output, and fluentd ships the standard output to Datadog. So in order to set up fluentd, you need a couple of things. You need a daemon set or a daemon set, which is basically a Kubernetes resource that tells Kubernetes, hey, this app needs to run on every single node. We also need a configuration file for fluentd called fluent.conf, which basically tells fluentd, for example, go read that log file, enrich it with all this metadata, and ship it to Datadog every 5 seconds. You can customize the configurations as you like. We also need a secret resource, which basically handles all of the sensitive data. For instance, the Datadog API. We don't want it hard-coded in the configurations. So you deploy all of this once, and every pod in the cluster automatically benefits from this. So let's recap what we've just discussed. Your main application should do one thing well, right? Sidecars handle the extra jobs without modifying the application, and they communicate through shared volumes. So what are the benefits? Well, the application stays focused on one particular thing, right? It only processes orders and it does nothing else. Another thing is that logging can't break the orders. If the sidecar fails, the main app keeps running. And lastly, no code changes are necessary. You added observability without touching the application code. So that's it for this video. I hope you have enjoyed it. If this helped you in any way, please leave a like and subscribe for more videos. Drop any questions in the comments below, and I'll see you next time.